CH3F, or fluoromethane, by Audrey Sayer, period 1. So what exactly is a Lewis dot diagram? Well, Lewis dot diagrams show the bonding between atoms of molecules, and they show the lone pairs of these molecules. We can also show the lone pair of electrons. How exactly? By using these 5 simple steps. Step 1. Figure out the valence electron count. So we will first begin looking at our molecule. Carbon has 4 valence electrons, hydrogen has 1, but because there are 3 molecules, you would multiply the 1 by 3, which equals 3. Fluorine then has 7 valence electrons. You can figure this out by looking at the periodic table. Then you add them all up together to equal 14, which is the total amount of valence electrons. That then brings us to step 2. In step 2, we have to figure out the number of pairs. To do this, we take our 14 valence electrons and divide them by 2, which will leave us with 7 pairs. Once we do that, it's time for step 3, where we will find the number of unshared pairs. During this step, it really helps if you draw the molecule to help find the unshared pairs. Here I drew out the carbon molecule and 3 hydrogen molecules followed by the fluorine molecule. I then filled in the number of valence electrons. As you can see, there are 3 pairs of unshared electrons. You will also notice there are 4 pairs of shared electrons. If you figure that out, you can move on to step 4, where you solve for the number of bonds. To do this, you take the 7 pairs and subtract the 3 unshared pairs. This will leave you with 4 bonds. Finally, in step 5, draw out the molecule. I'm first going to draw this without worrying about the bonding sites or where they pair up. I'm just going to do this to visualize it a little bit better. You then want to make sure that you fill each orbital before moving on to the next one. To draw our Lewis dot diagram correctly, we're going to have to place carbon at the center. We do this because hydrogen is on the outside, and because carbon is less electronegative than fluorine. Here, you will notice I place carbon at the center, and the 3 hydrogen molecules at the sides, and fluorine at the top. I'm then going to fill in the bonding sites with the electrons. Here, I've just drawn the 4 shared pairs. Now I'm drawing the 3 unshared pairs of fluorine. A way to tell if you drew your diagram correctly is if each orbital is filled. Hydrogen has 2 electrons in its outermost shell, so therefore we drew this correctly. Fluorine then follows the rule of octet, which means that it has 8 electrons in its outermost shell. Here you can see that by the 8 dots, or electrons, which means we drew this correctly. And you're done with your fluoromethane molecule. Next, you can work on your Lewis dot diagram of NH4+. This is also known as an ammonium ion. How do we do this? By following the same 5 steps we went over earlier. This first step, as you may remember, is to figure out the valence electrons. Nitrogen has 5 valence electrons and hydrogen has 1, but because we're using 4 hydrogen molecules, we have to multiply 1 by 4 to get 4. Then we subtract 1 because the plus sign on top means that we have lost an electron, leaving us with 8 valence electrons. This leads us to step 2, where we have to figure out the number of pairs. To figure that out, we're going to do the same thing as we did earlier, by taking our 8 valence electrons and dividing them by 2. This leaves us with 4 pairs. In step 3, we have to then find the number of unshared pairs. Now is a good time to draw the molecule. Nitrogen will go in the center because hydrogen is not allowed to be in the center. Then I will draw the valence electrons. Notice there are 0 unshared pairs. Step 4. Solve for the number of bonds. Take the 4 shared pairs and subtract the 0 unshared pairs. This will leave you with 4 bonds. This is what it will look like on the Lewis dot diagram. Each set of dots represents a pair or bond. Step 5. Draw the molecule. As I mentioned earlier, nitrogen is in the center, surrounded by the valence electrons and hydrogen molecules. But this time, I will be drawing the brackets around the entire structure and adding the plus sign to represent the polyatomic. And now you're done with your ammonium ion.